Hello viewers, my name is Shivasri Maiti and I am from Swami Vivekananda Institute of Modern Science, and today my topic is syntax and semantics, which is actually the part of principle of programming language subject. I have made this video specially for MSc Computer Science first year student, and the subject code is MCS 101. And I have made this video because I know that some of you have already missed my class, so I hope it would helpful for to those. It is helpful for all of you. So let's start with syntax and semantics part. So syntax actually could be considered as the formation of different kinds of program units, and semantics could be considered as the meaning of different kinds of program units. So semantics mean the meaning and the syntax at the formation. So here actually suppose I am giving one kind of example. See here I have written that if condition 1 then statement. That means the way I have written here, or the formation of one kind of programming language, which is actually called the syntax. And you know that there are several kind of programming languages are out there. So each of the programming language have their own syntax. Like C, it has different kind of syntax. For C++, it has different kind of syntax. But the semantics mean we have to write the formation of the program in a way such that it has the meaning, or it should be meaningful. That means from this entire statement, or it is actually understandable that if my condition 1 is true or got executed, then the statement would become executed. So semantics mean the meaning and the syntax mean the formation. So next one we have the description of syntax. First I want to tell all of you that computer doesn't understand other than 0 and 1. That means the binary numbers. So whatever you are giving the input through your keyboard, so actually those alphabet are first converted into its binary number, including its ASCII code value. Then actually it is transferred in, it is giving you the output. So a sentence or a statement is a string of characters over some alphabet. The syntax rules of a language specify which strings of character from the language alphabets are in the language. A language is a set of sentence, and whereas a lexeme is the lowest level of syntactic unit of language. It includes identifiers, deterrers, operators, and special words like sum, begin. A program is a string of lexeme, and the token is a category of lexeme like identifier. An identifier is a token that have lexemes or instances such as sum, total, in this way. That means all the special type of word or sentence what you actually use in your programming language, those are some kind of identifiers or lexemes. Like sum, begin, sum, total, in this way. So multiplication sign. So those special type of word actually are in the under the family or category of the lexemes or the identifier, whatever you say. Now we are coming in the language recognizer and language generator. Language, these are the two devices actually. One of the device actually reads input strings from the language, and the one kind of device which actually generates the sentence of a language. So first I'm coming in the language recognizer. These are actually language can be formally defined in two distinct ways. One is by recognition and another one is by generation. So a language the language recognizer is one kind of recognition device which reads input strings of the language and decides whether the input strings belong to that language. But it only determines whether given programs are in the language, like syntax analyzer part of a compiler. And the syntax analyzer, also known as parsers, determines whether the given programs are syntactically correct or not. And the language generators means a device that generates sentence of a language. One can determine if the syntax of a particular sentence is correct by comparing it to the structure of the generator. Now I'm coming in the grammatical part. Before that, I want to tell all of you that the formal language generation mechanism are usually called grammars. Grammars are commonly used to describe the syntax of programming language. There are several grammars are out there like CNF, CFG, that is context-free grammar, or BNF, that is Backus-Norm form, or EBNF, that is extended Backus-Norm form. I have provided all those things in different videos. Okay, so let's start with the context-free grammars. It is actually developed by Noam Chomsky in the mid 1950. Okay, these are the little bit history. It is for the knowing purpose. Okay, who describe four classes of generative devices or grammar that define four classes of language. Context-free and regular grammars are useful for describing the syntax of programming languages. Tokens of programming languages can be described by regular grammars. Entire programming languages can be described by context-free grammars. Now, first is that Backus-Norm form. Actually, it is invented by John Backus to describe ALGOL 58 syntax in 1959, which is equivalent to context-free grammar used for describing syntax. It is one kind of meta language, which is a language which is used to describe another language. Meta means a self. I mean, like metadata, a data which describe itself. Like same like meta language, which a language which could describe itself. Okay, and it uses abstraction to represent classes of syntactic structure and syntactic variables like non-terminal symbols. Here one kind of example I have provided, but I'm getting in details. Before that, here actually there are some rules for BNF. Okay, BNF describes the structure of an assignment statement, and it has both the LHS part and also the RHS part. LHS means left hand side and the RHS means right hand side. Okay, in LHS we should get the abstraction, which is actually called the non-terminal symbols, and in RHS the lexemes and the tokens part of the rules are called terminal symbols. Okay, and abstraction can have more than one RHS. Now the question is, why in BNF actually we are using the abstraction? See here, abstraction means when whatever problem is given or whatever derivation is given, we are not interested. I mean, how we actually solving the problem, that is not our interested area. We are just interested in, and that is what we have to do. How we are solving that problem, that is not the abstraction. Abstraction means we are getting the problem and what the problem told us to do. That means we are just interested about what to do, not how to do. Okay, that's why here abstraction is being used. So this is the given derivation, one given derivation is there, and this is the BNF of the given derivation. So see here, why we are writing this in this way. Here actually we are assigning some terminal and non-terminal here, but here actually what first we have to write in this way, then assign, then ID, okay, which is assigned to expr, okay, and the ID. Okay, now here see here we have only A, B, C, three variables, so we are taking either A or B or C. That's why you are writing by this or sign. And what we are doing here, either multiplication or addition, or the or we are just writing only either terminal or non-terminal part. That's why first we are taking here one kind of terminal part and non-terminal part. Then we are writing like ID, then either A or B or C, and here actually we are writing expr, then either we are adding those terminal and non-terminal, or multiplying those terminal and non-terminal, or we are writing the terminal and non-terminal itself. That means we are not interested how we are solving the problem. We are just writing down the abstraction. That means what we have to do. So we are first assigning the terminal and non-terminal things by using assigning sign. Then we are taking the variables. Then we are writing the addition and multiplication operation by giving the same or sign and writing the either the non-terminal or the terminal itself. Okay. So here is the entire thing, and in next video I am providing the entire concept of EVNF. Okay, so for now, okay, thank you. If you have any doubt or query, you can write in the comment box, and if you like my video, please like it, subscribe it, and share it, and you can share to your any friends, to your all your friends. Okay, thank you.